Okay, so this is problem 528, random pick with weight, medium difficulty. You're given a zero indexed array of positive integers w, where wi describes the weight of the ith index. You need to implement the function pick index, which randomly picks an index in that range and returns it. The probability of picking an index is of I is wi divided by the sum of w. So if w equals 1, 3, the probability of picking index 0 is 1 divided by 1 plus 3, which is 0.25, 25%. And the probability of picking index 1 is 3 divided by 4, which is 75%. Okay, so we're given w, it's 1 and 3. And we got sum of w, and this is 4. So then w divided by sum of w, well, actually, what we could do is we could do like a prefix sum array. So this would be 1 and 4. So then now, if you got prefix sum, we can call this like prefix, or we can call this like weighted. So if we divide it by the sum of w, so then this becomes 0.25 and then 1. So then the 0.25 basically is equivalent to this 25% here, and this 1, the 1 minus 0.25 is 70.75, which is equivalent to 75%. So then basically, and if you scale this to 100, this would be like 25 and 100. So then if you use like a random number generator, like let's say it's r equals random.random times 100. So that random is a random number from 0 to 1. So we could use it for here, but I'm just going to multiply by 100 so this is more clear. So then if you generate some number, let's say it's 27, then the 25 would basically consist of interval like 0 to 25, and this would be like 26 to 100. So then the 27 will fall within this range, so it'll be index 1. Whereas if you chose, if the r is like 17, then that would be from 0 to 25, so then it will fall into 25. So yeah, basically index 0. So, and if we use more numbers to make this more clear, let's say you got 0.14, 0.21, 0.25, like 0.56, 0.78, 0.91, 0.95, and so on. So then, this would be from 0 to 14 or 0 to 0.14, 15 to 21, 22 to 25, and so on. Yeah, so then, okay, so then, yeah, the same thing will apply. And then, let's say now r is some random number. Let's say it's 17. So then, how do we check which one r belongs to? Like, we could go through each of them one at a time, but that's going to be O of n time complexity. Basically, this pick index, each time it's called, you don't want to have O of n time complexity. We can make it faster and make it O of log n. It's okay if this initializer is O of n because we're only calling it once, but this pick index could be called many times. So that's why we want pick index to be faster than O of n. So O of log n is faster, and then a log n algorithm that can search for something in a list or array, first thing that comes to mind would be like a binary search. So then with a binary search, you would start with index at the midpoint of this list, and then you would check this 17 or less, or 0.7, whatever. And then if it's less than, because it's less than 0.56, it can be in this range. It could still be in a range from 0.26 to 0.56, so that's why we include the midpoint. So basically, if mid or prefix sum mid, if r is less than it, then you know that the right endpoint is going to be equal to mid, because it's still possible the mid index could contain that 17. We don't know yet. But we do know for sure that it will not be in anything greater than the 0.56. So that's why we said R equals to mid. If R greater than prefix sum of mid. So let's say this is 77. So we know that because this 0.56 contains from 0.26 to 0.56, the 0.77 has to be bigger than this. So it's going to be the interval that's going to contain it can be in is going to be in one of these intervals to the right of it. So then that's how we know that L then is going to be mid plus 1. And then else, so that R would equal prefix sum. So basically in that case, you'll have the 5, 6. And then, so basically we're going to make this inclusive. So this is 0.26 to 0.56, so it's going to include the 0.56. So therefore, you would just return mid. So this would go in this pick index function. So now that we have this, we can just start coding. So sum W, sum of W. Prefix sum, we're going to call it self.prefix sum because we need to use it in this pick index function. And then total would be 0. That's going to be our prefix sum. So for Wi and W, so total plus equals to Wi, self.prefix sum dot append. It'll be total times 100 divided by sum W. And then here we're going to have, so self.prefix sum. So now we just code the binary search. So L and R will initially be 0 and the length of the prefix sum array minus 1. Mid or while L less than R, mid equals L plus R minus L divided by 2. That's to prevent overflow, which would occur if you did if you just said mid equals to L plus R divided by 2. And then we got this. And then when we're done, it'll exit when L equals R, so then you just return one of them. And then that basically is returning the index. Just make sure this is correct. Yeah, this looks good. This looks good. Oh, we need the R, of course. So R is going to be just random.random times 100. Yeah. Okay, so that should do it. And it passes all test cases. So that's it. Thanks so much for watching this video.